Again, welcome to Java Programming 1. In this lecture, we are going to learn how to write, again, user-defined classes. This is the part 2 of the lectures on user-defined classes. So we're going to focus on class definitions, instance data, what is encapsulation, and also what is Java modifiers. Example, we spoke about that in our first lectures, talking about private, protected, and public. Also method declaration and parameters passing, and also constructors. So we already be using the predefined classes from Java API, that's Java Application Programming Interface. For example, we use the string class. We also use the math class, a random class to generate random numbers, etc. in our previous, again, lectures. That's a predefined classes. These are the classes that comes with the Java packages. Example will be the swing package for graphical user interface. We also have a math scanner class, which comes with a utility package, etc. So writing a class, here we said that the programs we have written in the previous example, as we said earlier, use classes that has been already defined in a Java standard library file system, which are the packages. Now we are going to begin to design programs that will rely on classes that we write ourselves. So this is a user-defined classes. So the classes that contains the main method, as we said earlier, the class that contains the main methods is just the starting point of a program. So other Java applications, the execution takes place in the main method. And we always have a main class. The main class actually is always the name of the Java file. And inside the main class, we can have the main method. We can also declare our user-defined classes inside the main class, or sometimes we may have it separate file, then link both together. So true object-oriented programming is based on defining classes that represent objects with a well-defined characteristics and functionality. So example of object-oriented programming languages can be Java, C++, we have Python, and the list will keep going. Even our program also have the concept of object-oriented programming. So these are some of the examples of a class. Here we focus on theory. The first part of the lectures, we focus on more into the implementation of Java classes, the syntax, and some examples of the methods of classes such as constructors, accessors, and mutators. Here we're going to focus a little bit more on theories. So example of a class is, as we mentioned earlier, always a class consists of two things: the characteristics of the class and also the behavior of the class. The characteristics is the same as the attributes. The behavior is the same as the operations or the functions that the class will be performing. So we have a first example of a student. So if we have a student class, an attribute or the characteristics of a student can be the name, the address, the major, or GPA. For example, a student class may not have a salary or hourly rate, because a student, we assume that a student is not an employee here. So these are some of the attributes. Then the operation of a student, we can set the address. Students have address. We can also set the major or get the major. We can also calculate the GPA. We can also return the number of credits the students has taken, etc. So the next example will be the rectangle. So we have a rectangle. We know it's an object. What are the characteristics of a rectangle? Will be the measurement. So for example, the length, the width, and also maybe the color of the rectangle. So that can be the attributes. Now the behavior or the operation, we can also find the area of a rectangle. We can find the parameter of a rectangle. So these are operations. We can also set the length, set the width, or even get the length, get the width, get the color. Another example is aquarium. The characteristics of aquarium can be the material that is being used. Also, the size of the aquarium can be the length, the width, the height. We know aquarium, we can find the volume of it. So since we have the material as attribute, we can set the material, we can set the length, set the width, set the height, and this will be the operations. Or we can even find the volume of the aquarium. So compute the volume or compute the fill weight. So the next will be a flight. So a flight also can be a class. And what are the attributes of a flight? It can be the airline number or the airline name, the flight number, the origin city, destination city, the current status. So here the operation can be, we can set the airline, we can set the flight number, we can also determine the status, and we can also find the origin or destination. And the last example will be employee. So an attribute of employee can be the name, department, title, salary. Then the operations of an employee, we can calculate the salary or compute the wages. If it has bonus, we can compute bonus. We can also compute the taxes the employee have to pay based on his wage. So again, these are just a few examples. The whole concept of object-oriented programming is to trying to come up, we have a problem. So the first thing we have to do is to identify the classes. And the best way we can identify classes or object from a problem specification is by identifying the nouns, and also the verbs will be the actions, so the operations. So if I have, as example, a project that I should implement a video rental system to a video rental store, maybe the two main objects I will recognize will be the video and also the customers, or also the employee. So I can start with these three objects, and as time goes on, during the analysis of the problem, maybe we can identify more classes. So we normally say the class is the blueprint of an object. So when we declare a class, it's more or less like we have an architectural who design a building, a blueprint of the building. Then based on the design, it can build as many houses as he wants. So the same here, I can have a class, declare a class named student. From that, in the main method, I can create as many student objects I want. And every object I create, I can use all the characteristics and also the operations of that particular class. And I think we see an example of this in our previous lectures. So classes and objects. We should recall from our overview of objects in Unit 1 that an object has a state and also behavior. And as we mentioned earlier, the state in our previous slide, in this case, the state will be our attributes, and the behavior again will be the operations. So always a class have these two items, state and behavior. So here we make an example here. We should consider a six-sided die. A singular is a dice. We know a dice can have a state and also it can have a behavior. The state will be either 1, 2, 3, 4, 5, 6. We have 6 sides, the side that we show up. So a state can be defined as which face is showing, phase 1, phase 2, up to 6. And the behavior of a dice can be roll the die. When I roll it, one face only will show up out of the 6. So the state will be the face of the die, and the behavior will be to roll the die. So we can represent a die by designing a class called die that models this state and also behavior. So I may have a class named die, and maybe I may have only one instant variable, which will be the face. And I may have one method, which would be to roll the die. And as we said earlier, in object-oriented programming, the most important method is the constructor, because anytime we create an object, the constructor will initialize the object. So we may have two types of constructor. Let's say a default constructor, and saying that by default, when we create a die, we want phase 1 to show or phase 2 to show. Or we may have a constructor with a parameter. It doesn't matter which phase to show. We have to set the phase when we create the object. So again, a class consists of a class consists of two things, the state and also the behavior. In this example, it's a die. A die have phases up to 6, 1 to 6. So a phase can be the instant variable, which will be the attribute or characteristics, and the behavior is to roll the die. Then I may have a constructor to initialize the die. And also maybe I may have a method to set the phase number between 1 to 6. Or maybe I will want to get the current phase of the die, so I may have a method to get. So this is the getters and accessors. And always we are going to instantiate as many die objects as we want using the die class in the main method. So in the main method, it's more or less like declaring a variable. So I may have the class name will be the data type, then the object name. Then we use the equal to the new, then the constructor. So a class can contain data declaration, as we said earlier, and also method declaration. So here we have a data declaration it's more or less like the way we always define variables. So here we have a int size and weight. Then we have a char for category. Then the method declaration. So the values of the data define the state of an object created from the class. And we made the instant variable values. That's why we always use the constructor to set the instant variables if we are using constructor with parameters. Without the parameters, then we set the default values for the instant variables of the class. So the functionality of the method defines the behaviors of the object. So for our die class, we might declare an integer called phase value. So this phase value can be a value between 1 to 6. That will represent the current value showing on the phase when we roll the die. One of the methods will roll the die by setting the new phase value. So anytime we roll a die, a new phase value will show up. And here, since it will be random, in a real life, when we roll a die, it's randomly between 1 to 6 will come up. So we can use a random class or write a method that will randomly generate one number between 1 to 6 anytime we roll the die. So we will want to design the die class so that it is a versatile and also reusable resources. Actually, that's one of the main advantage or benefit of object-oriented programming. I can have one class and we can reuse it as many times as we want. And the concept of inheritance also will help us understand the concept of reusable resources. So in the inheritance, I may have a class named person, a class named student, and maybe I created a new class named graduate student. But since graduate students is a person, I can let graduate student inherit everything from person class. And since graduate student also is a student, I may also let it inherit everything from student class. And also student can inherit everything from. So it's inheritance more or less like we are reusing the code, or in this case, the classes. So let's see a very good example here. So we say in a given program will probably not use all the operations of a given class. What we mean is that I may have a class with 10 methods, with maybe 2 or 3 instant variables. Most likely, we are not going to use all the 10 methods. I will only use the methods that I need. And anytime we are calling the method, we need to start with we use the dot operator start with the object name dot, then the method name. Then if any argument, you assign the argument to it. So let's see the example here. So here we have a rolling dice.java program. So this means our main program, main class is rolling dice. Then here we start with the main method first here. So in the main method here, we know execution will take place at main method. So we have a public static void main. So what are we doing? We create two objects, die1 and die2. And their type is what? The die class. Then we have a sum. Now, this is just the declaration of the object. Actually, we can do this in one line. I can have die1 equal to new die. But here we did this separate. We declare it first, and now we create the object using the new keyword with the constructor. Here we are using a default constructor. So whatever the default value is set to there. So we have the default constructor to create die1 and die2 objects. Now we call the method row, and we row both die1 and die2. So this is how in object-oriented, this is how we use the method. I've only used the method of a class by associating it with the object that we create. So die1.row, die2.row. So now we know we have two different phase value for die1. It can be the same value, it depends. This is randomly selecting values from 1 to 6. Then our goal here is we have a sum variable. We are going to add the two values that die1 and die2 display. So die1 is die1, then die2 is die2. Then later we add them together. So we roll the die1 again. Then we set the phase value of die2 to 4, which means we are not rolling it. We set it to 4. So die1, we have a new value. Then we print it again. Later now we are going to sum them. So here I'm going to sum die1, get the phase value, whatever the phase value is. Then die2, get the phase value. So we know die2 current phase value will be 4. By die1, the number can be between 1, it's row. So row gives us random value from 1 to 6. So whatever the two values are, first of all, we display those two values here. System.out.println die1 is die1, die2 is die2. Then we add the two values. Then we print the sum. Then we roll the dice again. So now we say sum equal die1.row plus die2.row. So we are going to generate a new two values for die1 and die2. Then we add it together. Then we print die1 and die2 again. Then we sum it. So this is the whole concept of object-oriented programming. So again, this is our main method. The goal of this program is to create a two dice object and then roll those two dice. The numbers that you generate, you print them out. That's the first print out. So we randomly generate the two. First of all, again, we declare our object die1, die2. Then we create our object using the new keyword with the constructor for die1, die2. After that, we roll it. Now we have the object. So now we can roll it. And anytime object-oriented programming, I'm using the methods in the class. I have to refer to the object that is using it. So die1 is using it, die2 is using it. So die1.row, die2.row. After we roll the first time, we display the result. Then we roll again die1, so we may get different value again. But die2, we didn't roll. We call the set phase value. We set the phase value to 4. Then we print both die1 and die2. So this is a second print out. Next, we find the sum of the die1 and die2. Then we also print it out. Then next, we also roll die1 and die2 again. This is the third time. Then we print the value of die1 and die2. Then we also print the sum of it. Now, what we need, again, this is our, again, this output here depends. Here we have the This is just a sample because this is randomly generate. Our first output, we generate 5 and 2. Second, we generate 1 and 4. And we had a 1 and 4, we get 5. Third, we generate 4 and 2. And when we had 4 and 2, we get 6. But again, this is our random. The only number that we will generate constantly will be the 4. Because the 4, we call the method set value. Actually, it's right here. Set the face value 4. The rest, we are using row. And row normally use a random method to generate. So this is our main method. This is where the execution takes place. Now, when we look at our program, we are using die class a lot. And we use the die class to create the die 1, die 2 objects. And die class should have a row method. You should also have a constructor die because we use it. And also we should have a method named get face value and also set face value. So now let's go and see our die class. So this is our die class, public class die. We set the mass, we declare a constant variable mass, we assign 6 to it. So the maximum face value is 6. Then we have our instant variable face value. We make it private. So as we said earlier, the dice, only one instant variable, the face value between 1 to 6. So our class here have only one instant variable face value. Then we have the default, our default constructor is always 1. So the default constructor, we set the face value to 1. It's very important. If we don't set the face value, then default always by default will be 0. And we know that in a die, there's no face value 0. So we have to set it to 1. Then next, the row. As we said earlier, row will generate a random number between 1 to 6. We use the random method before, the math class. This is called the static method. We don't need to create an object for it, which is the random. So we have the class name .random. Most important, since I'm going to print, I need a value from 1 to 6. We multiply by the maximum value, and this is 6. And if I have only maximum 6 here, it will print from 0 to 6. I don't want 0. So I say +1. So we start from 1. So this is the only thing we need. Randomly generating a value between 1 to 6. The value is int. Then we return the value back to the method. So the method returning type is int. So we have a return face value. We assign the face value, the random number we generated, we assign to the face value. And it will be a number from 1 to the mass. Mass is 6. It's a constant variable we declare. Then next, set the face value, straightforward. Since this is the argument is value, we set the value to the instant variable. So when I say set 4 here, it means I'm giving 4 to the instant variable. Instant variable again is the variable of the class. The value here is the variable for this method, the argument for this method. So we set the value to the face value. Then to get the face value, we just return the face value. Again, face value is the instant variable, so we get in it. This is called the accessor, and this is mutator. Mutator is to set, accessor is to get. Then the next, we have to string method. We said that this method automatically call when in a main method, we use the system.out.print or println. What this method does is that it's going to represent the object as a string type. So you return the string representation of the object, or in this case of the die. The die is the object. So this method, we don't call it. When we have system.out.println, this will be automatically called. And what we need here is that the integer dot to string face value. So the face value to string. So that's the die class. So we say the die class contains 2 data values. The constant mass. Again, the constant mass, I won't say it's an instant variable. That's just a constant variable. If I like, we don't need to even use it at all. In the method for the row, instead of saying times mass, I will say times 6. but our main instant variable is the phase value. So the class contains two data values, the mass constant variable and then the instant variable phase value. Then the row method uses the random method, as we saw it, because we want to generate a random number from 1 to 6. So use the random method of the math class to determine a new phase value. And there are also methods to explicitly set and retrieve the current value at any time, which is the set method mutator and get method accessor. Then also we need a constructor that will initialize our object for us. We also use the toString method. This, again, we don't need to use the toString method. So you can see that in lecture 1, part 1 of Java classes, I had an example of a clock class. In the clock class, when you look at the class diagram, or when you look at the clock class, we don't have no toString method. We don't really need to. But it's a good practice to define a toString method for the class. And here we say that toString method return the character strings that represent the object in some way. And it is called automatically, as we said earlier, it is called automatically when an object is concatenated to a string or when it's passed to the println method. So it is also convenient for debugging problems. We saw constructors, so as we said, as mentioned previously, a constructor is used to set up an object when it is initially created. So a constructor has the same name as the class. So we can say our constructor also name is die. A die constructor is used to set the initial phase value of each new die object to 1. Then we examine constructors in more detail later in this chapter. Then data scope, again, in Java, we have, when we declare variable, we always have two major types of variable. We have the global variable and also we have a local variable. Local variable is only can be seen by the method where it is declared. So that's why it's called local. So the method that the variable is declared, only that method can use that variable. It's only seen. Global variable means, again, the variable is declared outside all the methods. So it can be seen by any method in the class. And normally here we use the term class level variable. So that's example would be the instance variable. Instance variable can be used by the class, any method in the class, because it's seen by all. But when I declare a method and I'm using that method and I have a variable declared inside that method, then only that method can use it, which is called local. So here we say the scope of data is the area in a program in which the data can be referenced or used. Data declared at the class level can be referenced by all methods in that class. So at class level, all the methods can use it in the class. Now, data declared within a method can be only used in that method. And that method is called the local data or local variable. So in the die class, the variable result is declared inside the toString method. So it's local. Only toString method can use the variable result. But the variable phase value is a class level. It can be used by all the method. So a variable declared at the class level, such as phase value, is called the instance data. Each instant object has its own instant variable. So a class declares the type of data, but it does not reserve memory space for it. When we declare a class, it's just more or less like a type of a data. There's no memory. Now, when we create the object using the class type, that's when, again, with the new keyword, that's when an array object is created with a memory space allocated for it. So here we say instant data. We can show two die objects from the rolling dice program as follows. So we can see die 1 after the constructor, we set the value phase 5. Die 2, phase 2. So each object maintains its own face value. Then we also have the UML diagram, which stands for the Unified Modeling Language. In this section, we only use the class diagram. A UML diagram have up to somewhere around 14 different diagrams, mostly used in the software engineering or software design, analysis and design courses. For example, we have an activity diagram, state diagram. Use case diagram is very common. A use case diagram, you are designing the system, how it's going to interact with the outside world. Example, the actors, or if any automated system that the program will interact with, you specify that. Here again, we're just going through the UML class diagram. And this is the example of it. The class diagram consists of 3 rows. The first row is the name of the class. Second row will be again the instant variables or the characteristics of the class. And the third row again will be the methods. So we can see our die class, we have only one instant variable. So face value, the name of the instant variable, the type is int. And in some textbooks, we can have a plus or minus in the front. So we can have a plus means and a private or public minus. So here we just have, again, the instant variable, the method. We have the row, returning type is int. Set face, returning type is void. Get face, returning type is int. And we also have to string, returning type is string. We can also have a die, the constructor, returning type none. Constructor don't have no void, nothing. Just die, then open parentheses and close for default. With a parameter, we can use the int value also. So quick check here. Here we say, what's the relationship between a class and an object? So the solution is here. Class again is more or less like the blueprint. It's just the declaration. Object is the real deal. It has a memory space. So we say a class is the definition or pattern or blueprint of an object. It defines the data that will be managed by an object, but doesn't reserve the memory space. Rather, the object reserves the memory space. And normally, we create the object in the main method, and we can use one class to create as many objects as we want. So a class is more or less like a blueprint, or here we say definition pattern of an object. Then quick check again, where is the instant data declare? Remember the keyword is instance. Anytime we hear the keyword instance, then we are referring to the class level. And what is the scope of the instant data again? Class level. What is the local variable? These are the local data or local variable declared in a specific method. So let's see the result. Where is the instant data declared? Always at the class level. And what is the scope of instant data? It can be referenced in any method of the class. So if it's a class level, any method inside the class can use it. But what is local data? Local data is declared within a method, and only that method have access to it or can send it. So we're going to end the lectures here. And in this lecture again, the same. Here we consider more into the theory, the concept of object-oriented programming, how we can implement a class, what a class consists of. And we use the Java syntax to elaborate it. And again, wish everybody the best. Thank you.